Welcome back to your notes on trig graphs. And before we move on to the trig graphs of tangent, cotangent, secant, and cosecant, I wanted to kind of put it all together from your transformation exploration. So remember that A is your amplitude. Okay, it's essentially your vertical stretch from transformations and other functions. B changes the period, so it's a horizontal stretch or shrink. And your new period, if we're talking about sine or cosine functions, will be 2 pi divided by b, or 360 degrees divided by b. For tangent, as we saw yesterday, we know that our period is pi, so with b, the period becomes pi divided by b, or 180 degrees divided by b. C is inside your function, so it's a horizontal shift, so you go left or right. D is outside your function, so it's a vertical shift, and you go up or down. Okay, so now we're going to talk about graphing cosecant of x or secant of x. So the basic rules are that we're going to graph the reciprocal function. Remember that for cosecant of x, that is 1 over sine of x. And secant of x is 1 over cosine x. So we'll graph either sine x or cosine x. We'll kind of dot that in. We'll draw vertical asymptotes where the reciprocal function equals 0 before the vertical shifts. And then we'll use the asymptotes to draw in the other parts of the graph. All right, so let's take a look at our first cosecant function. So we know that, actually I'm going to blow this up a little bit more for us. There we go. All right, so we're given a domain restriction of 0 to 2 pi, which is nice. We know that the reciprocal function is sine of x. Our amplitude is going to be 1 because there's no number in front, or there's the coefficient of 1 in front of the cosecant of x. Our period is going to be 2 pi. Our phase shift, which is essentially our horizontal shift, is left pi over 4. And then there's no vertical shift. So on your notes, these graphs did not come out as clearly as they are here. You can see that there's supposed to be 12 blocks, and I'll use that to represent one period so that I can mark in our major angles within that period. Fortunately, this is pretty straightforward. It's 2 pi, pi over 2, pi, 3 pi over 2, negative pi over 2. I really don't need to go past negative pi because we only shifted left pi over 4. And then I'll mark 1 and negative 1 on the y-axis to represent our amplitudes. So if we're going to dot in the sine function, and I'll make that a different color. So we know that we're shifting left pi over 4, which is essentially halfway between 0 and negative pi over 2. So sine starts at 0. So we'll put in a point there. Then we'll go forward pi over 2 to 1, 0, negative 1, and 0 again. And each time the points are roughly halfway between the two major angles. So on your notes, if you want, you can actually go ahead and mark in pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, we need to put in the asymptotes for cosecant. So anywhere that the original function was, the reciprocal function was 0, we get an asymptote. And we would get one at negative pi over 4, and I'll dot it in, but it's not part of our original domain. So I may end up erasing it because we know that the domain restriction we have is 0 to pi over 2. So we're really only concerned with everything to the right of the x-axis. Now, once we have these asymptotes in, we can go ahead and draw in the reciprocal function. And we know that sine dotted that way, which means that the reciprocal function will go the opposite way. Oops, and I need to stop again at, there we go, at 0. So it'll look something like that. And then the same thing happens down between 3 pi over 4 and 7 pi over 4. Sine continued that way and would actually continue up. Our reciprocal cosecant function will go down away from the sine function and up that way. Okay, so there's our first example. Our second example, we're graphing 2 secant of 2x plus 1. So we'll run through the various changes, and then we will go ahead and graph it. So in this case, we have an amplitude of 2 from here. Our period is 2 pi divided by 2 from this 2, making it pi. And we have no phase shift, but we do have a vertical shift of up 1. Okay, so we'll go ahead and mark off our major angles using the 12 blocks to represent the pi. On your notes, you can just really put in the four major angles based on your period, and that'll be fine. So if this is pi, then that's pi over 2, that's pi over 4, 3 pi over 4, negative pi over 4. All right, and then we need to mark our amplitudes or our y values. Since the amplitude is 2 and the vertical shift is up 1, our y values will go from negative 1 to 3. All right, and we'll keep in mind that we do have a domain restriction. We'll kind of run the graph in and then worry about where we cut it off. Secant is 1 over cosine, so let's remind ourselves of that. We're going to be graphing a cosine function. All right, so since there's no phase shift, we would start at the origin. We know that cosine normally starts high, so it would start at 2, but we go up 1, so it starts at 0, 3. Then at pi over 4, we would be at 0, but we've shifted up 1. So we need to remind ourselves that this is where essentially an asymptote is going to occur because we were 0. But we'll draw the rest of the cosine graph in first. Then we'll continue low, middle, and high. And then we'll go back the other direction. Okay, and our cosine graph would look like that. Now, as I said earlier, we know that we have asymptotes wherever the cosine was equal to 0 before we shifted up 1. So that'll be 3 pi over 4, pi over 4, negative pi over 4, and negative 3 pi over 4. And then our reciprocal function goes away from the original function. So it'll face down, and then face up, and face down. And everything that's in black is what is part of our domain restriction. I'll go ahead and erase the part of the graph that I dotted in that's outside of our domain, so we're not confused as to whether or not we stayed inside our domain. but I think sometimes it helps to graph in the whole function so you can see the picture and then use your eraser as you need to. The rules for graphing tangent and cotangent graphs are a little more involved, but they help make the graph a little cleaner to look at. So your first step is to find two consecutive asymptotes by finding an interval containing one period, okay? So you're gonna go from negative pi over 2 to pi over 2, and then you solve for x, and those will give you your asymptotes. Next, you're gonna identify an x-intercept, which is midway or halfway between the consecutive asymptotes. Once you do that, you're going to divide again, so points that are 1/4 and 3/4 of the way between the consecutive asymptotes. And those points have the y-coordinates of negative a and positive a, respectively. And then we'll graph one full function, and we'll add additional cycles as we need to. So let's go ahead and do an example. All right, so we have y equals 3 tan 2x for a specific domain. So the first thing we want to do is find the asymptotes. So we'll go from negative pi over 2, and then we'll take the 2x, that's our bx minus c, to pi over 2, and then we'll solve that, and we'll get negative pi over 4 is less than x, which is less than pi over 4. So those are our consecutive asymptotes. Then our x-intercept is midway between the asymptotes. So halfway between negative pi over 4 and pi over 4 is 0. So our x-intercept is 0, 0. And then we need to be a quarter of the way between 0, negative pi over 4, and pi over 4. So essentially we're going to divide those in half again to this part and this part. So our x values will be negative pi over 8 and pi over 8. And then the y values are negative a and a, so negative 3 and 3. So then we can go ahead and graph that. And since these are a little bit different, you can scale it really however you want. I'm going to spread it out and use 2 blocks for pi over 8, then pi over 4, negative pi over 8, negative pi over 4. And then we need to put in our y values of 3 and negative 3. So we will graph the asymptotes first. Graph the y-intercept, which is the origin, or the x-intercept, excuse me, which is the origin. Then we'll do negative pi over 8, negative 3, and pi over 8, positive 3. And now we have one full cycle of our tangent graph. Our original domain was from negative pi over 4, which we have, to 3 pi over 4. So we'll go ahead and just add another period, and that will take us to our 3 pi over 4. So this is 3 pi over 8, pi over 2, 5 pi over 8, and 3 pi over 4. And then we just mirror exactly what we did. Okay, for cotangent graphs, the change is that you go from 0 to pi instead of from negative pi over 2 to pi over 2, as you do in the tangent graphs. Everything else is roughly the same. You're going to find the x-intercept by being midway between the two consecutive asymptotes. You're going to find points that are 1/4 and 3/4 of the way, but this time the values are a and negative a. And then we'll graph one full function. All right, so here's our example. First thing we're going to do is find the asymptotes. So this time we use 0 is less than pi over 2x. That's our bx minus c, which is less than pi. When we solve for x, we need to divide by pi over 2, which gives us 0 is less than x, which is less than 2, because we have pi divided by pi over 2, which is pi times 2 over pi. Pi's crossed out, and we get 2. Our x-intercept is halfway between 0 and 2. So our x-intercept has an x value of 1, so it's 1 comma 0. And then our 2 points are halfway, or a quarter of the way and 3/4 of the way through. So that would be a half and 1 1/2. And our y values are a, so 1/2 from right here, and negative a, so negative 1/2. And then we can go ahead and graph. So since we're going from 0 to 2, and it's basically one quote-unquote period, I'll use the 12 box, make it nice and straight, or nice and spread out, really. So that's 2, 1, 1/2, 1/2. And then you can use the same scaling on the y-axis or different scaling. It's really up to you, as long as you mark it off so that I can tell what you've done. So we'll call it 1, negative 1. Okay, we'll put in the asymptotes at x equals 0 and x equals 2. We have the point 1/2, or 1, 0, 1/2, 1/2, 1 1/2, negative 1/2, and so it goes up like this and down like that. If you are not given a domain restriction, then my directions are always going to be to graph 2 full periods. So we'll go ahead and graph another period to the left, just because we have space on it, and that way we don't have to extend it out to the right. We'll have another asymptote at x equals negative 2. And then if we just kind of picked this up and pretended that we had transported it over to repeat the cycle, there is our second cycle of a cotangent graph. As always, let me know if you have any questions.